we are going to talk about types of chemical reactions. So we're just going to talk about the main types of reactions that we see. So down below I have those listed. The first one, combination reactions. Second, decomposition reactions. Third, combustion reactions. And the last one, redox reactions. And redox, stands for oxidation reduction or reduction oxidation, whichever way you want to list it. So redox is just the abbreviation for oxidation reduction. All right, so let's look at each of these in a little more detail. So let's look at the first type, a combination reaction. So sometimes this is also called a composition reaction, but this reaction makes a single substance from two or more reactants. Now, you might produce more than one molecule of the product, but there's only one substance produced. So an example is down below. We have iron, Fe, reacting with oxygen, O2, and that's going to make iron 3 oxide. Okay, so iron 3 oxide is actually known as rust. So you can see a picture off to the side there of some red rust. And notice that this is a balanced equation. So in order to have the same number of atoms on the reactant side and on the product side, there's a ratio of 4 iron atoms to 3 oxygen molecules, and we create 2 rust molecules. So even though we created multiple iron 3 oxide molecules in this reaction, there's only one overall product that we made, which is rust. So again, in a combination reaction, we're just combining multiple reactants to make one thing. Now the next type of reaction is a decomposition reaction. So this is the reverse of a combination reaction. In this type of reaction, a single substance is going to become 2 or more products. And again, there might be more than one molecule of the reactant to start, or multiple copies of that reactant, but there's only one overall substance initially. So down below I have another example. So this one has potassium chlorate, KClO3. So this is an ionic compound, and this is going to decompose into potassium chloride, KCl, and oxygen gas. So potassium chloride is shown off to the right. It looks really similar to sodium chloride, NaCl. And notice the ratios here. We do start with 2 copies of the reactant, and we form 2 molecules or ionic compounds of KCl and 3 oxygen molecules. All right, so even though we have, multiple of the reactant, there is only one type of reactant. The next type of reaction is a combustion reaction, and this occurs when a hydrocarbon, which is a compound made up of only carbons and hydrogens, reacts with oxygen to produce carbon dioxide and water. So again, a hydrocarbon only contains carbon and hydrogen atoms, and those might be in different amounts depending on what type of hydrocarbon you have. But again, this is going to react with oxygen in the air, and we end up with carbon dioxide and water. So hydrocarbons are typically used as fuel because their combustion reaction releases very large amounts of energy in the form of heat. So as an example, uh, propane, which contains 3 carbons and 8 hydrogens, is commonly used as a fuel source in gas grills. So, summer's coming up, and if you have a grill at home, you might need tanks of propane to keep it going. And again, we use propane because it can react with oxygen and produce large amounts of energy, along with the products we talked about, carbon dioxide and water. So notice that in this reaction down below, the balanced one, we need 5 molecules of oxygen to react with every molecule of propane, and we produce 3 molecules of carbon dioxide and 4 molecules of water as a result. So if you see these two products in a reaction, CO2 and H2O, that tells you that you have a combustion reaction. There are some exceptions to that, but these are pretty typical products for combustion. All right, so let's practice. Let's classify each of the following reactions as either a combination reaction, a decomposition reaction, or a combustion reaction. So pause the video, see if you can figure that out, and then we'll go over it together. All right, so A, how would we classify this reaction? Combination. So we're combining 2 things to make 1 thing. So again, we only have 1 product. So in this reaction, we're combining aluminum and oxygen to create aluminum oxide. All right, B, how would we categorize that reaction? Combustion. So I see the CO2 and H2O, so that has to be combustion. So this is a combustion reaction for methane, which earlier we said was natural gas. So this is what's usually present in houses to run things like water tanks or your stove, oven. Now, methane is odorless, and we need to make sure it's smelly so that we can detect any methane leaks. So usually natural gas is spiked with some sort of sulfur compound because sulfur smells really bad. So if there is a methane leak, you typically smell that kind of sulfury smell. So if you've ever wondered why natural gas smells so bad, that's why. All right, C. What type of reaction do we have here? A decomposition reaction. So in this reaction, we're starting with calcium chloride, so only 1 type of reactant, and that is decomposing into calcium oxide and carbon dioxide gas. All right, so the last type of reaction is a reduction oxidation reaction, which again we can also call a redox reaction. Now, we're actually going to talk about this in the next video because there are some other details that go along with redox reactions that I want to go over with you. But in general, in a redox reaction, we have a movement of electrons between atoms. So we'll get into that next time. I'll see you then.